All right, hopefully the read to learn was somewhat informative. So right now what we're going to be doing is we're going to be going through the guided notes. So please make sure that you're following along as we're doing this. What we're going to be doing right now is we're going to be comparing and contrasting rational numbers with irrational numbers. Now, we just did the read to learn, and the read to learn was able to show us that there are two different categories of numbers, those that are rational and those that are irrational. A good way of remembering the difference is if you've ever been told that or heard someone say like, oh, don't be irrational, or don't be irrational. Yeah, it typically means like don't be crazy, don't be ridiculous, don't be over the top. And that's kind of what irrational numbers are. They're the numbers that when you see, they are two things. Irrational numbers are non-repeating, non-terminal or terminating or ending. Non-terminal, again, terminal just means ending. Non-repeating, non-terminal decimals. Oh my gosh, that was awful. Non-repeating, non-terminal decimals. These cannot be written. I can spell written as a fraction. So the whole idea here is you can't write an irrational number as a fraction. For example, you cannot write, let's say my number was 0.538713 ... as a fraction, because we don't know what's happening here. It is non-repeating and it is non-terminal. What that means basically is an irrational number. An irrational number is unpredictable. Except for like some very key cases such as pi, which we know what pi is to a certain amount. It's continued still being calculated in terms of hundreds of billions of different decimal places out. It is unpredictable when it's presented to you. So if I gave you this number, for example, and I said, okay, what comes next? You wouldn't be able to tell me necessarily. So that would make it an irrational number. It's unpredictable. So based on these terms, based on this right here, let's come up with some examples of irrational numbers. Well, let's use this one, 0.5, what did I write? 387.8713 ... This is non-repeating. There are no numbers that repeat themselves. And it is non-terminal. This ellipsis right here, this 3 dots, states that it is not going to end. So it's non-terminal, meaning unending. And I can't write this as a fraction. I can't put this over 1 because this ellipsis right here, these 3 dots, make it so I can't necessarily put it over 1 because I don't know what comes next. So some other examples, let me make some space here. Some other examples of common irrational numbers. As we saw in the read to learn, we have square root of 2, which is 1.414, so on and so forth. Again, this right here says it's not repeating. It says that it is unending. So this is irrational. Again, non-repeating, non-terminal. These are just never going to end. Another example, pi. 3.14159 dot dot dot. It's not going to end. It's not going to repeat. Non-terminal, non-repeating. Nope. Another example. Students in my class know this one very well. Phi. Phi is 1.61, so on and so forth, also known as the golden ratio. Other examples. Square root of 3. That does not end nicely. These are all examples of irrational numbers. So, based on that, let's try to come up with some things that are rational numbers. Well, if irrational means that they're non-repeating, non-terminal, then rational numbers would logically be either terminal, meaning they end, or repetitive, meaning they continually repeat. Rational numbers, long story short, are any number that can be represented or written, same basic idea here, represented as a fraction or a ratio. Fraction or ratio. So any number that can be represented as a fraction or a ratio. So some obvious ones we can think of. I don't know, let's say 5. 5 terminates, it ends, right? And it is not necessarily repetitive, but if you really want to, it could be 0, 0, 0, 0, 0, so on and so forth forever. It terminates, it ends, or it is repetitive. It can also be written as a fraction. 5 is a fraction. It is 5 over 1. Other examples of rational numbers. Let me get rid of all of this so we have space to work. So 5 is a rational number. Other examples of rational numbers. 3.333 repeating. This is predictable. Remember we said that irrational numbers are unpredictable. Unpredictable. These are unpredictable. Well, this is predictable. If I said, okay, what's the next number? You would hopefully tell me 3, because this line here says they repeat. If we suddenly got a 5 in here, then this symbol is wrong. So it can't happen that way. This is rational because it's predictable, it is repeating. It doesn't end, but it's repeating. Another one that ends. Let's say 7. Hooray. That is terminal. It ends at 7. Again, that can be written as a ratio of 7 over 1. This can be written as a ratio of 3 and 1/3 because 333, that is that. 0.08, what was it up here? 0.083333. 3 repeating is 1/12, as it said. So it follows all our criteria. It can be written as a ratio of 1/12. It repeats, so it is repeating. These are some examples of rational numbers. Now what you're going to do is you're going to come down to this section, guided practice. I encourage you to pause and try to classify A through F as rational or irrational. After that, again, I encourage you to explain why in these boxes provided right here. Why are the numbers you classified as rational rational? Why are the numbers you classified as irrational irrational? Please pause the video here, give this a shot, check your answers in a moment. All right, hopefully this was reasonably simple for you. We're going to be going through these really quickly. One by one, let's do A. A, I see a 0.33 with this line right here, which means it's repeating. I know as I just annoyingly stressed 100 times, repeating decimals are rational. So 0.33 repeating is rational. So now let's move on to B. 0.489. There is no ellipsis. There is no ellipsis here, which means that ends at 9. It's done. So we're going to include B as well, 0.489. Then we look at the square root of 2. I can remember, I literally use that as an example right here for something that is irrational because it doesn't end. It's non-terminal, non-repeating. So I say radical 2 or the square root of 2. 413. Well, that's a ratio, that's a fraction. And by definition, anything that can be written as a fraction is rational. So I come down and I say 413. Pi, again, literally an example I used right here. So pi goes in irrational. Now I'm sure some of you were a little bit confused by this. So the best way to remember this is pi is involved. Pi is involved in this, and therefore if there is an irrational number being added, subtracted, multiplied, or divided. If you are adding, subtracting, multiplying, or dividing any irrational number, your answer is always irrational. So there we go. That is unless, of course, you have pi divided by pi, but that's a whole different situation. Typically, the way to remember this is if there's an irrational number being involved, an irrational and a rational, you're going to get an irrational number. So I could say, I don't know, pi divided by 8. That is also irrational. Phi times 2. That is also irrational because I am multiplying, dividing, adding or subtracting by an irrational number. Now, those were just examples. Don't worry about those. So we've kind of nicely organized these into two groups of 3, where we have our rationals and our irrationals. I encourage you to come down here and make sure that your answers match up somewhere along the lines of an explanation of saying rational numbers please don't write exactly what I write because this is not a complete sentence, can be any number represented as a ratio or fraction, not ration, ratio or fraction. And irrational is the exact opposite. It's any number that can't be shown as a ratio or fraction. Any number that cannot be shown as a ratio or fraction. Let me get rid of my awful handwriting here. So what you're going to do now is you're going to pause your video. You're going to come down to compare and order on your partner practice. Wish you best of luck with that. If you do have any questions, please feel free to raise your hand. And again, all you are doing here is you're going to be saying, well, point A is 1.5. Well, point A is right here, and I come up here and I make sure to label it. If you do not label it, you'll probably get confused. You're going to be estimating the value of these numbers as we practiced yesterday, such that we're saying, well, 17 is between what two perfect squares? Well, 16 and 25. That'd be 4. That'd be 5. I know it's between these two perfect squares. So, which is it closer to? It seems to be much closer to 16, because that's only by 1. and that is by 8, significantly closer. So my guess would be somewhere around 4.1-ish. I could be wrong, 4.2, but when I plot point B, I'm going to say, well, 4 point, yeah, here. And that's point B. So please go through these. Make sure that you're using complete sentences in your explanation during your partner practice.